Okay, we are back now with Josh and Paul for the second part. Now is ARM64 node pools on AKS, Azure Kubernetes Service. Paul, look what I have here.
I need one of those.
Have you heard about this thing?
Yeah.
That's the new Volterra. That's the called Windows Dev Kit 2023 desktop.
Yeah.
And that's pretty much ARM64 machine with Windows 11. Everything's working. All the software that you need, even Teams, Visual Studio, Visual Studio Code, WSL2, they're all working as ARM64 now, like native ARM64 pretty much.
I'm jealous. I've only seen pictures of it.
That's like 32 gig of memory. I'm enjoying a lot. I just disconnected here to show, but I'm enjoying a lot. And tell me, what are you going to show for us? And by the way, if you don't follow the channel, subscribe, follow us, hit the ring bell and to get notifications. But that's a segue from Josh was talking about signing container image with Node-RED v2 using GitHub Actions. And we also have ARM64 going GA. That's available for the users to go to production. Let's bring the cost a little bit down as well because we pay less for the nodes on the AKS cluster. Some applications get even faster using maybe less resource. How do you see that? And I'm doing some presentation already using ARM64. I'm enjoying a lot. And tell me, what are you going to show for us?
Yeah, so today I'm going to show you, I'm just going to give you a little bit of information about what it means to actually deploy your application workloads into ARM64 node pools. Some of the things that you should be considering. I ran across a few stumbling blocks. I just want to share some of that with you all. So let me go ahead and show just a few slides, not too many, but just a few slides just to kind of level set. And so
just before we start, Josh, what do you want to see there? Anything special, Josh? You want to see ARM64? Have you played with that before?
No, I'm brand new to this, so looking forward to seeing it.
That's great. Let's go for it.
All right. So first of all, for anybody, hopefully by now you've heard of what ARM and ARM64 is, but just in case you did not, just a level set here, ARM, not to be confused with Azure ARM or Azure Resource Manager. This is actually the processor, right? So ARM is the acronym for Advanced Risk Machine. It has historically been used for mobile devices, IoT devices, just the small devices that we've been using for decades, right? It's been powering. It's the chip that has been powering these devices, and literally there's like billions and billions and billions of them out there. And why is that? Well, it's because it's a very low powered device, very efficient device. And the thing that's really exciting now is that there has been for the past, I don't even know how many years, but for quite some number of years now, there's been an extension to ARM, right? And so now we're moving into ARM64, where it's starting to power a lot more bigger machines, beefier machines, right? We're talking about like your M1 MacBook. If you have one, you'll know how powerful it is and how long the battery life on that thing lasts for. So it's pretty cool. And then we're also seeing it in different cloud providers. And now, I think as of like a month ago, we've finally announced the GA of using ARM64 processors on your Azure virtual machines, right? So again, why does it matter? I think, George, you covered a lot of it, right? It's really the low power footprint is what makes it ideal, right? Low power footprint equals what? Lower costs, right? And so you're going to get a better price to performance on these chips. And it may actually help organizations meet their sustainability goals, right? And in some cases, because of the architecture and because of the way that it processes its computations, in some applications, it might be actually a little bit quicker, right? As you mentioned, George. So, but the things that I wanted to cover here are things that you should be considering before you do your kubectl apply on your workload, right? So, and especially in the context of, using this on Azure Kubernetes servers. So number one thing I want you to know and pick up on is the SKU, right? Selecting the right SKU for the deployment. And then number two is picking or making sure that your container image supports that multi-platform architecture. And then number three, there's a few best practices around your Kubernetes deployment manifest that you should also worry about. And after that, it should be pretty smooth. All right, so I told you I will not have too many slides, so that's it. So let's just go ahead and jump into, oops, I did not mean to do that. Yeah.
And I was reminded that, like you said, Paul, we have Azure VMs for ARM64 as well.
Oh yeah.
It's not just on AKS. You can just create a VM and have your developer environment on ARM64. You can have the Project Volterra thing here.
Right.
And now on AKS, I think that's the biggest thing for production, to going for production.
Right. And that's the one thing that we have to know, that, yeah, it is, the ARM64 is primarily for the virtual machine SKUs. And what powers AKS? Well, virtual machines on the back end powers AKS. And so the things that you need to be aware of are the SKUs that we have available. Okay. There's a blog post that went out, and I will link it, or George can probably link it in the show notes. But the SKUs that went out, they're generally going to start with the DP, like, capital D.
Can you zoom in a little bit, Paul? Just a little bit.
Yeah, let me just maximize this. There we go. So the SKUs that you're going to be looking at are going to be the DP SKUs, and also the EP SKUs. Okay, so just remember those two. The Ds are generally going to be for general purpose virtual machines, right? And then the Es are going to be for your memory intensive workloads, right? And so you can see here, like, the specs that we have, and these are the SKUs that you're going to be using for your deployment, right? And so on an E series virtual machine, you can get up to 32 cores and up to 208 gigabytes of RAM. Whereas on the general purpose machines, you can get a whole lot more cores, but not as much, right? So just remember, the D is for general purpose and E is for memory intensive. And that's pretty much it. When you deploy an AKS node pool, it's no different than deploying any other node pool. And so what you need to do is, I have some code here. I'm just going to hide it real quick.
I think, Paul, on AKS, we normally get not like big nodes, because we are like maybe middle-sized nodes where we can spread, the failover in multiple nodes. And if one node fails, we can move the workloads across the nodes.
Right. Right.
But for the big VMs, I think for, not for AKS, but for other workloads, will be fine.
Right. Right. And that's exactly right, because AKS, it can scale out elastically, and yeah, you generally don't want to use larger node pools in AKS because there's a limitation on how many pods you can actually run. So yeah, it's probably a better idea just to have more smaller virtual machines in your cluster. So yeah, good call out. I just wanted to show the command real quick. Hopefully you can see this pretty clearly, but the command to actually add a node pool is no different than any other command, right? Adding any other node pool, that is. The only difference here is just adding in the SKU. And so that's why understanding what that SKU is that you're going to be targeting is very important for that. Okay.
Can you zoom in a little bit more, Paul?
Yeah, there we go. Yeah, so there's nothing special that you have to say, hey, I want an ARM64 node pool. No, the SKU actually tells you that, okay? I actually published a blog post today on Dev2, and I did talk about how if you were to use a ephemeral OS disk, just be mindful that you do need a virtual machine SKU that offers a temp storage disk. So, and that's what that little lowercase d designates there. So, yeah, it's pretty important concept. Okay. The next thing that you need to be mindful about is the container image that you want to deploy. So just because you have the AKS cluster out there with the ARM64 node pool doesn't mean that you can just go and deploy any container image to it, right? You have to make sure that your container image supports multi-platform architectures. And so that's one thing that I ran into when I attempted to deploy the Azure voting app to my AKS cluster. Okay, you hopefully if you've gone through some of the Azure quick start guides, you might have seen this application here. Let me go pull this IP and let's go. You might have seen this app, right? Azure voting app. Go for cats and dogs, right? So yay. So when I went to go try it out when it first got announced, I didn't have an app to deploy. So I'm like, well, let's go deploy the Azure voting app, right? And problem is with the Azure voting app, it is actually based on an image that doesn't support. Let me go pull up this URL. Okay. So this image that they ask you to deploy, right? So this is a quick start guide in our docs. The image that they ask you to deploy actually doesn't support the
you have to zoom in for a little
ARM64.
bit. You have to zoom in 2 times.
There we go.
More, a little bit more.
A little bit more. Okay. There we
There
go.
you go.
Yeah. So that the image that they ask you to deploy doesn't support it, and you can actually test it out using a Docker command, right? So if I clear this, and let me just get some stuff out the way. So if I do a Docker, oops, I don't know what's going on with my terminal. Okay, acting a little wonky. Let's do Docker manifest inspect, and if I paste in the container image, you'll see I'll get a whole bunch of stuff back. And it's normally formatted a little bit better than this, but yeah, I get a whole bunch of stuff back and there's no platform in here, right? So it clearly is not suitable for deployment on my ARM64 cluster. And so what does that mean? Well, that means you have to go digging around into your container image definition, right? And then you have to start digging and digging and digging until you find the base layer, unfortunately. And so that's kind of the rabbit hole that I went down. Is I started to go into all of these. And if you go to Docker Hub, if you go to hub.docker.com, and if I search for this user's container, so it's a UWSGI Nginx Flask. And let me pop this up. So the Azure Vote container image is actually sourcing from this, right? And then if you start to look at the arch that it's deployed in, the OS arch, you'll see none of these support ARM64. They're all AMD64, right? And so what I did was just by digging into each of these container images, because they're all linked to Docker, you can kind of see, where is it at? 36. You can kind of see that they're all it's all chained together, right? And so you just keep digging in and finding out. Yeah, you just keep digging in and finding out like what architecture this thing supports, And so if I go to hub.docker.com again.
Is it fair though, from like the architecture standpoint, that whatever the base layer, no matter how far down you go, the architecture is going to be the same on the other images, right? The downstream images. So like even whatever one that you found, instead of having like going down through the chain helps you find out what the base image is, and then like how you would kind of refactor it or recode it to fit it. But the architecture is architecture, and whatever that image supports is going to be true from the base on down.
Right. And so because the Azure voting app relied on this particular image, which is not support ARM, and when we dug in, we saw this base image also doesn't support ARM. What I did find was that the lowest layer of the container image, Python 3.6 Buster, actually does support ARM. And so we can start to build off of that. Unfortunately, though, what that means is it means I have to go rebuild it.
So that's a new fun fact for me. So like the core base image of all of that did support it, but then some child, or if that's a proper term, image, like downstream image, decided to change it. So the child can manipulate the architecture, but the core could ideally go all the way through. Interesting.
Yeah.
Okay, I didn't know that. That's cool.
Yeah. So what that meant was I had to basically refactor the entire Docker image. So what I did was I just munged the two other Docker files together to create this particular Docker file, which is sourcing from Python 3.9 Buster now. So even got it up to date a little bit on the Python versioning, right?
Well, just like a summary here, just a summary. Like if someone watching is kind of an image that's like more than maybe 3 years old, they don't have support for ARM64, or the latest image they have, then if you're going to start from some image, double check if they have support for ARM64. But all the recent and latest image they are going to have. But if someone built like a long time ago and never updated, then you cannot start from that image. You have to go back for the base image. Like from Python, the like 3.9, the latest Python.
So that's super important, is understanding the layers that are in your container images. Once you have that sorted out, you can use a tool. It's an add-on to Docker, and so you can use Docker BuildX, right? And so BuildX is like I mentioned, it's an extension to Docker. And what this tool allows you to do is actually use a single Docker file, because there's a couple of approaches to building multi-platform container images. You can create a Docker file for each platform, like one for AMD and one for ARM64. And you can build those two container images, and then you can create a single manifest file that kind of says, hey, I support these two platforms. But to me, that was a little bit more work than I wanted to do. And so that's when I decided to just take the Docker BuildX approach, right? So it's just installing BuildX onto your machine. And you would use BuildX kind of in a similar way that you would with any other Docker build command. And so it's just Docker BuildX build. And then what you need to do is you need to call out the platform that you want to build for, right? So here I'm saying build for Linux AMD64, and then also build for Linux ARM64. And then I gave it a tag, and I'm publishing it up to my GitHub repository. And then the BuildX will actually build those two images for you, create a single manifest, and push it all up into the GitHub repository, right? And so if I jump over into my GitHub repository and I look at packages and I search for Azure Vote, you see, you can see that there's a new Azure Vote front container image here. And you'll notice here, OS Arch says 2. And so if I click on that, you can see that now this image supports both AMD64 and ARM64. Okay. And then of course, we don't always want to build locally from the command line. And so that's where I added this workflow file. So I know, Josh, you were running ACR build task to build a container. In this case, what I did was in my GitHub action, I've actually added a step to include the Docker buildx setup. And then in this particular scenario, I am pushing to Azure Container Registry. Locally, I just pushed it up to GitHub Registry. But in my action, I'm using Azure Docker login to log into my ACR. And then I'm issuing the same exact command, the Docker buildx build command, to actually push it up to Azure Container Registry. Okay. And then one final consideration that you should include is number one. Let me go over to my deployment. So I'll go over to my Kubernetes cluster. I'll go over to my node pool. And here is my system node pool. And what I like to do, especially if I'm running system node pools and user node pools, what you want to do is you want to taint the system node pool so that all it's going to run is your system pods and none of your workload pods will be there. Or Kubernetes won't try to schedule your applications to that. Now I have an ARM64 node pool, and you can see again, it's running that particular SKU, the D4PDS SKU, right? But when you get into writing your manifest files, what you should be doing is, and I'll show you this manifest file here. Let's close that. To actually, is it not here? Not here, but what you should be doing is node selector arch. You can actually do something like that, right? This way, I mean, for this particular image, it doesn't matter. I built it in, to support 2 different platforms. So all it says, hey, I want to run it on Linux nodes. But if you have a ARM64 only container image and you want to make sure that it only attempts to be scheduled on that particular node that supports it, in your pod spec, you can add a node selector and then add this kubernetes.io/arch and then ARM64. And then that will make sure that it only gets scheduled on the nodes that support ARM64. Okay. Yeah, and that's it. I think those are the top 3 considerations that I had for all this. And as a final step in all this, what I would suggest, and as you know, George and Josh, we've been building a lot of labs in our open source labs repository on GitHub. And so you can go ahead and try this out for yourself. I have 2 links here, 2 different options. One, you can actually deploy the entire cluster and the ARM64 node pool using Bicep. But if Bicep is not your flavor, we do have a Terraform option too. So you can actually deploy the cluster using Terraform and then deploy the exact same Azure voting sample app. So, okay.
Yeah, then you have a call for action there. That's your next step. Just give a go and try. Yeah. But I also like to ask people to leave a comment for us and let us know what you want to watch next. You want to see Josh showing, how we validate the sign of the image when you deploy something. We're gonna see us going deeper on how to build these buildx on ACR, for example. How can you build multiple architectures on using ACR build? I think that you can do that using ACR task. At the moment, they don't have one command that you can build for everything. There's a lot of things that people can ask, and just let us know what's next. Leave comments here. I think it was great. Everything that you show, I'm using as well for my demos.
Cool.
And I also note I have to put in, to set the architecture to 64 to avoid being deployed on the system node pool, or even to be deployed in another Linux node pool.
Yeah.
Because if you have another node pool, Linux node pool, then ARM64 is Linux, then it's going to try to deploy that.
Yeah.
And you have to make sure that you do both.
And I'm starting to get into a habit of doing that a little bit more in my manifest, because you can have Linux, Windows, AMD, ARM, and now Wasm. And so, you have a Kubernetes cluster that can support almost anything. And so it's always good to just call it out and give the scheduler a little bit of a hint, so.
That sounds great. Josh, what do you think? You're going to give a go now?
Yeah, I learned quite a bit. I didn't really, it's kind of new to that whole area. I kind of knew with ARM and the kind of the basic efficiencies, but I learned a lot with Docker and in containers in the selector. So I appreciated the demo.
Thank you, Paul. Thank you, Josh. And let us know what you want to watch next. Subscribe to the channel and see you on the next one. Bye-bye.
Thanks all. Bye.